Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. The lasting legacy of John von Neumann, shaping the future of technology, science, and society. John von Neumann was born on December 28, 1903, in Budapest, Hungary. To put it simply, his life was nothing short of extraordinary. His father, a banker, and his mother, a cultured homemaker, might have expected him to follow a traditional path. But von Neumann wasn't your average kid, he was a prodigy. I wonder if geniuses like this really require such a high level of talent. By age 3, he was already speaking 5 languages fluently. By 4, he was mentally solving complex mathematical problems that would leave most adults scratching their heads. Genius? Absolutely. But not just any kind of genius, he had a mind that was far ahead of his time. Despite his exceptional intellect, von Neumann was no robot. He had an infectious sense of humor that made him a favorite in academic circles. Picture this, a math genius who could crack a joke during a dry lecture, keeping everyone engaged. He didn't just master abstract concepts, he also mastered the art of connecting with people. In his early years, his family hoped he would take over his father's banking business, but von Neumann had different plans. At the University of Budapest, he gravitated toward mathematics. It didn't take long before his talent outshone everyone around him, and he quickly became a star in the academic world. His brilliance wasn't just confined to the classroom, he was a pioneer, constantly pushing the boundaries of what was possible in math and logic. After finishing his degree, von Neumann moved to Göttingen, Germany, the mecca of mathematics at the time. Here, he rubbed shoulders with the likes of David Hilbert and Niels Bohr, the rock stars of the mathematical world. His academic achievements started to pile up, and soon, his name became synonymous with breakthrough ideas in set theory, mathematical logic, and quantum mechanics. He wasn't just learning from the giants, he was adding his own theories to the mix, making waves across Europe. But von Neumann wasn't just a thinker, he was a doer. In 1929, the U.S. economy faced the onset of the Great Depression. Stock market crashes, rising unemployment, and social unrest marked the beginning of a turbulent era in American history. He moved to the United States to join the Institute for Advanced Study at Princeton. This move marked a pivotal point in his life. It wasn't just the opportunity to work alongside Albert Einstein or Niels Bohr that excited von Neumann, it was the chance to bring his cross-disciplinary ideas to life. He wasn't satisfied with being a math genius, he wanted to impact physics, economics, and even computer science. In Princeton, von Neumann's work began to cross the boundaries between fields. While his contemporaries were focused on pure math, he turned his attention to real-world applications. The result? A theoretical framework that would change the course of history, the von Neumann architecture. Let's pause here for a moment. You might be asking, what exactly is this von Neumann architecture? Well, if you've ever used a computer, yes, even if you're just watching this video on your phone, you've interacted with it. Von Neumann's big idea was to create a design where the computer could store both the program and the data in the same memory. Think of it as having a filing cabinet with 2 drawers, one for your documents, programs, and one for your random stuff, data. In today's terms, this is what allows you to run multiple programs simultaneously, from browsing the web to editing videos. Before von Neumann, computers were these giant, clunky machines that could only handle one task at a time. Imagine using a computer that could only do one thing. Boring, right? But von Neumann's architecture was like a supercharger for computers. It allowed them to store programs, execute them, and switch between tasks seamlessly. With his architecture, the foundation for everything from personal computers to smartphones was set. In fact, von Neumann didn't just stop at designing computers, he essentially rewrote how we understand computing itself. His ideas didn't just revolutionize hardware, they paved the way for software development, programming languages, and even the concept of operating systems. Today's flexible, fast, and efficient computers owe their existence to this one breakthrough idea. Von Neumann's work on computing wasn't just about making things faster. He also had a knack for simplifying the complex. Before his architecture, computers were far from user-friendly. They were like massive calculators that needed a team of engineers to operate. After von Neumann's intervention, the game changed. He helped turn a bulky, intimidating machine into something that could fit in your pocket and work on your lap. His design unlocked the potential for smaller, more efficient computers, which only continued to shrink as time went on. But von Neumann's genius wasn't just about logic and algorithms, he was a man of culture and wit, someone who could balance a scientific mind with an understanding of people. His colleagues adored him not just for his brainpower but for his charismatic personality. He had an ability to bring people together, whether it was to discuss complex theories or to share a good laugh. Despite being one of the most brilliant minds of his time, von Neumann was never distant or inaccessible. He had a way of making even the most complicated theories approachable and engaging. His influence didn't just end with computers. Von Neumann made contributions to quantum mechanics, game theory, economics, and even military strategy. He was everywhere shaping ideas that would impact both scientific and non-scientific fields. His work in game theory, for example, influenced modern economics, helping to shape strategies for everything from markets to military operations. Von Neumann's approach was always interdisciplinary. He didn't just stay in his lane, he saw the connections between fields and used his wide-ranging expertise to make groundbreaking advances. His legacy is more than just a set of equations or designs, it's the idea that true innovation happens when we stop looking at the world in silos. It's about seeing the big picture and finding ways to connect the dots. So, when you use your phone or sit down in front of your laptop, take a moment to appreciate von Neumann's work. His architecture is the backbone of modern computing, and without it, we wouldn't have the technology that powers our world today. Now, back to the early days of computing. Imagine being in the 1940s, when computers were massive, slow, and awkward. They could barely store any data, let alone run programs. Then came von Neumann's idea, a computer that could store and execute programs at the same time. It was a mind-blowing concept at the time, but it worked, and it worked well. This wasn't just a theoretical exercise, it was a practical solution that transformed the way computers were designed. Von Neumann's architecture didn't just influence one generation of computers, it set the stage for the next 70 years of technological evolution. From the giant, room-sized computers of the mid-20th century to the tiny, powerful smartphones in our pockets today, his ideas have been at the core of every leap forward in computing technology. In short, von Neumann wasn't just a mathematician or a scientist, he was a visionary. He saw the future of technology before anyone else did, and his contributions continue to shape the world we live in today. Whether he was cracking jokes or cracking codes, von Neumann's impact on science, technology, and culture is immeasurable. And that, my friends, is why his legacy will never be forgotten. ENIAC was a groundbreaking machine in its time, but it didn't have the kind of design principles that we take for granted today. Without von Neumann's architecture, it was limited, efficient, yes, but not nearly as flexible or powerful as it could have been. Enter von Neumann's design, which turned ENIAC from a heavy-duty number cruncher into a computer that could actually process programs and data in the same memory. A major game changer. In fact, von Neumann's architecture is so foundational that it's still the backbone of every computer we use today, from massive supercomputers to the smartphones in our pockets. Next time you're playing a game or browsing social media on your computer or phone, remember, all of this is built on the principles von Neumann laid out. Without him, we might still be dealing with punch cards and slow, inefficient computers. But thanks to his vision, computing entered a new era of speed and flexibility. You've probably heard of game theory. It sounds like a fancy term for advanced board games, but actually, it's one of von Neumann's most influential contributions to economics, politics, and even military strategy. Alongside economist Oscar Morgenstern, von Neumann co-authored Theory of Games and Economic Behavior, a book that didn't just shake up the world of economics, it revolutionized multiple fields. One of the key ideas they introduced was the concept of the zero-sum game. Simply put, in a zero-sum game, one person's gain is another person's loss. Think about it like this: if you're playing poker, for every chip you win, someone else has to lose it. This idea totally flipped how we view competition. It's no longer just about winning, it's about understanding the delicate balance of gains and losses. But von Neumann's brilliance didn't stop there. His zero-sum game theory didn't just apply to games like poker. It became a model for understanding market competition, business strategies, and even international politics. Businesses use game theory to determine everything from pricing to product launches. It's about predicting the moves of competitors and making the smartest choices. Even more mind-blowing, von Neumann's theories extended to international relations and military strategy. During the Cold War, when the world was teetering on the edge of nuclear war, game theory was used to help strategize the tense standoff between superpowers. Rather than relying on guesswork, decision-makers could apply a mathematical model to anticipate the other side's moves. The Cold War wasn't just about politics, it was a high-stakes game of chess, with nuclear weapons as the ultimate prize. Von Neumann didn't just use mathematics to predict the outcomes of games, he used it to create a universal framework for decision-making. Whether you're negotiating a business deal, managing a conflict, or just deciding how to divide up resources in a group project, game theory is there, guiding your choices. Von Neumann's mathematical genius wasn't just confined to abstract theories. When World War II broke out, he was recruited by the US government to work on the Manhattan Project, the secret program that developed the atomic bomb. But here's the twist: von Neumann wasn't interested in the bomb itself. His concern? The math behind nuclear explosions. Yes, you heard that right, nuclear explosions were a math problem to him. Von Neumann developed crucial mathematical models to help scientists predict the timing of nuclear reactions and the power of explosions. His work wasn't about creating bombs, it was about using math to understand how explosions could be controlled and studied. These models helped test and design nuclear weapons with far more precision than ever before. But let's be real, this wasn't a comfortable role for von Neumann. While his mind was focused on the math, he knew that the outcome of his work could change the course of history. And it did. His calculations helped make nuclear weapons a reality, and soon, the world was dealing with the terrifying potential of atomic bombs. Though von Neumann never intended for his work to be used in warfare, he faced a moral dilemma. As a scientist, his job was to push the boundaries of knowledge. But as a human being, he couldn't ignore the devastating consequences of the tools he was helping to create. It's safe to say he didn't sleep easily at night, knowing that his work could be used to destroy entire cities. Yet, von Neumann didn't step away from the project. He firmly believed that science itself wasn't inherently good or evil, it was a tool. How it was used was a different question. So, he chose to continue contributing, supporting the effort to create better models, even as he wrestled with the implications of those models being used to devastate the world. Von Neumann wasn't just a genius mathematician, he was a pioneer of interdisciplinary thinking. He didn't stay confined to the narrow walls of one field of study. In his world, math, physics, and economics were connected, not separate. He was one of the first to truly see the value in blending different fields to solve complex problems. And that's exactly what he did throughout his career. He laid the groundwork for computer science, built the foundation for game theory, and even reshaped economics with his understanding of competition. More than just ideas, von Neumann's theories provided practical frameworks that scientists, economists, and even political leaders could use to navigate the complexities of the real world. Today, when you use a computer, you're directly benefiting from von Neumann's vision. His architecture still drives everything from high-performance computing to the apps on your phone. In business, politics, and even military strategy, his game theory continues to shape decisions and outcomes. But let's not forget von Neumann's greatest legacy, his charm. He wasn't just a scientist, he was a social figure, a personality. He had this incredible ability to make people laugh, even while discussing complex theories. Whether it was cracking a joke in the middle of a tense debate or using humor to break down complicated ideas, von Neumann made science approachable, engaging, and downright fun. Despite his towering achievements, von Neumann wasn't a workaholic who neglected his personal life. He maintained strong, loving relationships with his family. His home was his sanctuary, a place where he could recharge, find balance, and keep his creativity flowing. In fact, it was this balance between work and family that allowed him to tackle some of the world's most daunting challenges with a clear mind. Von Neumann's legacy goes far beyond his scientific discoveries. His ability to bring humor and warmth to even the most difficult academic discussions, his role in shaping the future of technology, and his complex moral reflections on the consequences of scientific discovery all contribute to the legend that is John von Neumann. Today, his contributions continue to shape the world. Whether you're calculating an investment decision, engaging in a political negotiation, or just using a smartphone, you're interacting with von Neumann's ideas. And every time you make a strategic choice, you might just be unknowingly applying game theory to your own life. Von Neumann's influence isn't confined to academia or technology, it's woven into the very fabric of our modern world. John von Neumann's name still resonates today, echoing through the halls of science and technology. His life, a legendary tale in history, continues to illuminate our world, shaping the digital landscape in ways most of us take for granted. Whether it's the phone in your pocket or the computer you're using at work, von Neumann's architecture is quietly at work behind the scenes. Have you ever wondered why computers are so fast, so smart? A big part of that is thanks to von Neumann's work decades ago, laying a foundation that remains unbeaten today. This mathematical genius wasn't just a hacker, he pressed the accelerate button for the entire computing industry, making progress faster and more efficient. From education to tech industries, von Neumann's influence is felt far and wide. Today, countless students, researchers, and entrepreneurs are building on the path he created. If you've ever coded, you've probably heard of von Neumann's architecture, the core framework of computers, the very soul of every computer's brain. Every bit of data stored, every instruction executed, relies on the model he designed. In the field of computing, von Neumann's ideas are considered the gold standard. His influence didn't just impact theoretical developments, it directly shaped how computer science is taught today. In classrooms across the globe, students still learn about the fundamental concepts von Neumann proposed all those years ago. Quantum computing and the legacy of von Neumann. And let's talk about quantum computing. Yes, quantum computing. Does it seem like something far in the future? Well, think again. The influence von Neumann had on computing theory continues to impact the cutting-edge technologies of today, including quantum computing. The revolutionary breakthroughs in supercomputing, artificial intelligence, and quantum computing are all built on von Neumann's architectural foundation. He was ahead of his time, recognizing that future computing would need more parallel processing power. This insight set the stage for the rapid advancements in hardware and AI. The very technologies that seem like sci-fi today, quantum computers, supercomputers, and AI, are all deeply connected to the framework von Neumann designed. Von Neumann's legacy goes far beyond just computer technology. His interdisciplinary approach continues to shape the work of countless scientists. From quantum mechanics to economics, from game theory to physics, his innovative ideas span multiple fields. Scientists today still look to von Neumann's research as a source of inspiration, pushing their own disciplines forward. Even in modern scientific dilemmas, von Neumann's way of thinking remains the key to solving some of today's most complex problems. He didn't just create academic brilliance for himself, he gave the global scientific community a blueprint for cross-disciplinary collaboration. The importance of interdisciplinary thinking. Today's interdisciplinary research is a continuation of von Neumann's methodology. He showed us that science shouldn't be confined by the boundaries of a single discipline. He himself broke down the walls between mathematics, physics, and computer science, leaving his mark with every step he took. Von Neumann's academic legacy goes far beyond shaping the present-day tech world. The computer architecture, game theory, and his advocacy for interdisciplinary research are now fundamental pillars of modern science and society. No matter if you're a computer scientist, a quantum computing researcher, or a financial expert using game theory, von Neumann's brilliance is with you. His contributions are foundational to our information age. From computer chips to quantum labs, from economic models to military strategies, von Neumann's influence is everywhere. The impact of his work will never fade with time. As von Neumann once said, scientific progress is not just about theoretical innovation, it's about crossing the boundaries of thought. This is his deepest legacy, transcending disciplines, eras, and the very limits of our thinking. The multidisciplinary genius. Von Neumann was not just a mathematical genius. He was a visionary who transformed the way science is done. His influence extends far beyond the equations he solved. It's in how he changed the approach to scientific research. His multidisciplinary vision and innovative spirit continue to inspire scientists worldwide. Today, whether we're making breakthroughs in computer science or pushing the boundaries of quantum computing, von Neumann's ideas still guide the way. Each of his theoretical breakthroughs opened up new realms of exploration. Every path of thought he pioneered deepened our understanding of the world. Von Neumann solved some of the most complex technological and societal problems with the sharp precision of mathematical thinking. He didn't limit himself to one field, he leaped across mathematics, physics, computer science, economics, and beyond. He turned computing from theory into practice and used game theory to inform global negotiations. Von Neumann's contributions have long since surpassed his time. Today, the tech world we live in continues to be a reflection of his ideas. His innovation, his cross-disciplinary thinking, has become the very backbone of modern science and technology. He didn't just change the world of academia, he redefined what it means to be a scientist in the modern world. The future, powered by von Neumann. Von Neumann's legacy is more than just a series of academic achievements. It's about the universal applicability of his ideas. He provided tools for future generations of scientists, enabling them to explore broader horizons. His vision of the future has already become our present reality. Whether you're a software engineer or an economist, von Neumann's thinking continues to shape how we understand the world. His ideas influence the computers we use, the artificial intelligence that's transforming industries, and even our everyday decisions. His interdisciplinary approach is embedded in the DNA of modern technology. Von Neumann was not just part of history, his thoughts are still shaping the future. Have you ever wondered how von Neumann's academic contributions still affect us today? When you swipe your phone, type on your computer, or make decisions in business, are you being influenced by his genius? This isn't just about his academic achievements, it's a testament to the depth of his intellectual legacy. Von Neumann's influence remains as powerful and relevant today as it ever was, and his work will continue to shape the future for generations to come. The people who change the world. Usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.